So getting back to our proofs now, I want to write a proof given the information, the diagram, and what we're trying to prove. So here's what's given. Segment AC bisects segment BD, and then segment AC is congruent to segment AD. I want to try to prove triangle ABC is congruent to triangle ADC, it should be. So in order to prove that the two triangles are congruent, we need to start figuring out our statements and our reasons. The first statement could be AC bisects BD. That's definitely given. I could also write as my first statement, segment AB is congruent to segment AD. That's also given, but let's just take a look at the first statement. AC, so this segment right here, bisects BD. You have to know and figure out what it means for something to be a bisector. If something's a bisector of a segment, that means it cuts it into two congruent parts, which then also means that segment BC is congruent to segment CD. So BC is congruent to CD. That's a definition of a segment bisector. Again, if something bisects a segment, cuts it into two congruent parts. And then, since we haven't written it yet, I could have combined the first statement and added AB is congruent to AD as a given. I'm going to put it as statement number 3. That's also a given. So here's what we have so far. Two sides in one triangle congruent to two sides in a second triangle. That doesn't fit one of the requirements of triangle congruence yet. It doesn't fit side angle side. It doesn't fit side side side, nor does it fit hypotenuse leg. And hopefully you figured out you're going to rule out hypotenuse leg. It's not given that AC is perpendicular to BC, so you can't assume that it's a right triangle. But here's what you have to figure out from the diagram. AC, that segment, is in both of the triangles. That segment is congruent with itself. So that could be your next statement. Segment AC is congruent to segment AC. And then the reason is it's the reflexive property. If you just write that, that's fine. If you write for reflexive property of equality, that's actually not correct. This is not an equal sign. It would be the reflexive property of congruence, or even more specifically, the reflexive property of congruent segments. And then in the triangle ABC, we have three sides of that triangle congruent to three sides of triangle ADC. So those two triangles are congruent specifically by side, side, side. Triangle ABC is congruent to triangle ADC, again by side, side, side. You can write out all the words if you want. Really, we almost always use just the abbreviations for triangle congruence. But that's the proof for this specific example.